Hello everyone, welcome to Natus and Aptitude Well. This is the third set of LCM and HCF questions in the lane of all competitive exams. Already we discussed 20 questions in the previous sets LCM HCF 1 and LCM HCF 2. Now this is the LCM HCF 3 21st question. The length and breadth of a room are 10 meters 75 centimeters and 8 meters 25 centimeters respectively. The floor is to be paved with a square tiles of a largest possible size. The size of the tile is. See, here, this is in one rectangular part. This is one rectangular part like this. But what we require square tiles, right? Suppose that measurements is this one. Suppose that measurement is this one. How many tiles are to be fixed? Let us take an example that is equal to 100 tiles are required. Suppose tile size is large, then how many tiles? The number of tiles must be less than 100 or not, right? Suppose the size is more than this one, then what happen? The number of tiles must be less than 100. See, here if the tile size is increases, the number of tiles must be decreases. What is the question? The floor is to be placed square tiles of the largest possible size. Here we required directly given the largest possible size. Now what we require, the size of a tile is, right? Here no need to find out how many tiles are required. So what number of tiles are required, that is the secondary. Now what happened? Suppose this is the largest tile, and let us take this length is equal to x and this length is also equal to x. Next, what is the question? The floor is to be paved with a square tiles of the largest possible. So this length, the tile length must be a factor of this entire length or not. In the same way, tile breadth is must be a factor of this rectangular breadth. Here these two are same. Now this length is a factor of this total length. This breadth is a factor of this breadth. What happened here? This length is a factor of this total length. This breadth is a factor of this total breadth. So what we require, largest side, that is equal to largest factor or not. What is the largest factor? That is the highest common factor of both length and width. What is the length here? That length is equal to 10 meters 75 centimeters, and next this one 8 meters 25 centimeters. 8 meters 25 centimeters, right? Here what we required? We required the highest common factor of 10 meters 75 centimeters, comma 8 meters 25 centimeters. See, here two ways are there. Either you will convert these measurements into centimeters or convert these measurements into meters. Better to convert these measurements into meters, that is the best one. Why? Because here 10 meters 75 centimeters is equal to 10 meters and 75 by 100 or not. This centimeters converted into meters. 8 meters 25 centimeters. So 25 by 100. So what happened? This is equal to 10 3 by 4 and this is equal to 8 1 by 4. These are in the mixed fractions. Now we will convert these mixed fractions into improper fractions. So this is equal to 43 by 4 and this is equal to 33 by 4. Now what we require? We require the HCF of these numbers. Now what is the HCF of fractions? That is equal to HCF of numerators by LCM of denominators or not. What is the HCF of 43 and 33? That is equal to 1 or not. Why? Because these two numbers are co-primes. Next, what is the LCM of 4 and 4? That is equal to 4. So 1 by 4 meters. What is the 1 by 4 meters? That is equal to 25 centimeters or not. What we require? The length, the x is equal to 25 centimeters. What we require? The size of a tile. So that is equal to 25 centimeters by 25 centimeters. Option A is the correct answer. Next example. What is the greatest number that will exactly divide 312, 351 and 650? The greatest number exactly divide. That means that greatest number is a factor of these three numbers or not. Now what we require? We require the highest common factor of these numbers. Now the numbers are 312, 351 and 650. Now here already we discussed in the first video how to calculate HCF of more than two numbers. Now what is the common factor of these numbers? Let us take 2 is not possible, 3 is not possible, etc. For suppose if you will divide this number with 13 and this is equal to 2 times 52, 4 times and 2 times 26, 91, this is equal to 7 and this is equal to 50. What is the common factor of these numbers? There is no common factor of these three numbers. So what is the HCF of these three numbers? That is equal to 13. So what is the answer? Answer option B is the correct answer. Next example, what is the greatest number that will divide 29, 60 and 103 will leave the remainders 5, 12 and 7 respectively. Here the numbers are 29, 60, 103. And what are the reminders? Reminders is, suppose let us take that greatest number is equal to x. If this number is divided by x, the remainder is equal to 5. If this number is divided by x, the remainder is equal to 12. If this number is divided by x, the remainder is equal to 7. Now, see, suppose this number is divided by x, the remainder equal to 5. If you will subtract 5 from this number, then what happens? This is equal to 24. Now, suppose x is the greatest number. If x is divided this number, the remainder is equal to 5. And if x is divided this number, what is the remainder? That is 0 or none. And this is equal to 48 and this one equal to 96. See, if divide this number, the remainder is 0. Divide this number, remainder is 0. Divide this number, remainder is 0. If the remainder is 0, what is the meaning of the statement? That is a common factor of these numbers or not. What we require? Greatest number. Here we require the greatest common factor of or highest common factor of these numbers. Numbers are 24, 48 and 96. What is the common factor of these numbers? Let us take 2, 12, 24 and 48. What is the common factor? 2. This is equal to 6, 12 and 24. What is the common factor? Again 2 and this is equal to 3, 6 and 12. What is the common factor? That is equal to 3. So 1, 2, 4. Now what we require? What is there any common factor of these three numbers? No. So what is the HCF? That is 2 into 2 into 2 into 3. Right? So 2 into 2 into 2 into 3. This is equal to 24. So option A is the correct answer. Next example. Find the least number which is exactly divisible by this number. Here divisible by, what is it divisible by? That is this that number must be a multiple of these numbers or not. Okay, and what we require least number. Here we will find out the LCM of these numbers. So the given numbers are 8, 12, 15 and 21. Now you will, my favorite method, you will convert these numbers into product of the prime factors, that is 2 cube, this is 2 square into 3 and this is 3 into 5 and this is equal to 3 into 7. Now what are the bases? 2, 3, 5 and 7. Now what we require? Here we find out the highest power of each and every number. What is the highest power of 2? 3, highest power of 3, 1, highest power of 5, 1, highest power of 7, 1. So this product is the least common multiple of these numbers. So 8 into 3 into 5 into 7. So this is equal to 40 into 21. So that is equal to 840. Option D is the correct answer. Next one. Find the greatest number less than 900 which is divisible by 8, 12, and 28. What we require? Greatest number that less than 900. Okay, see, which is divisible by, this is the very important point. Okay, generally people think that greatest number then apply HCF, suppose least number then apply LCM. That is not the way. Here the way is divisible by or divides. Suppose it divides, then only that is a factor. Divisible by, that is a multiple. Now what we require? Greatest number less than 900 divisible by, numbers are 8, 12, and 28. That number must be exactly divisible by these numbers. That means that number must be a multiple of these three numbers, common multiple. First, you will find out what is the least common multiple of these numbers. This is 2 cube, this is 2 square into 3, and this is 2 square into 7. What is the LCM? 2 cube into 3 into 7, right? 8 into 3 into 7. So this is equal 56 into 3, that is equal to 168. This number is exactly divisible by these numbers 8, 12, and 28. But what we require? Greatest number which is less than 900. Now you will divide this 900 with 168. 168 5 times 840, remainder is equal to 60. Now if you subtract 60 from this number, then that number is exactly divisible by, that is 840 is exactly divisible by 168, which is exactly divisible by 8, 12, and 28. So what is the answer? Answer is equal to option C. Now so many think that what we require? Less than 900. So this is not a correct answer. Leave it. And the remaining three options. Of these three options, what is the, which is the nearer to 900? So 840. 840 is the correct answer. That is the one way. But my dear students, don't do like that. You must thorough with concept. Always options are not favorable to us. Okay. If you thoroughly with the concept, then only you will apply the, you will get the answer from options. Unless until you are thorough with concept, don't do this method. Don't do this method. That is equal to you will get the options. You will get the answer from options, etc. Next example. What greatest number can be subtracted from 10,000 so that the remainder may be divisible by 32, 36, 48, and 54? See, what greatest number can be subtracted from 10,000 so that the remainder may be, this is very important, the remainder may be divisible by 32, 36, 48, and 54, divisible by, so that number must be a multiple of these numbers, right? So the given numbers are 32, 36, 48, and 54. This is equal to the power of 5, and 36. 2 square into 3 square, 48. 2 power 4 into 3, and this is 3 into 2 into 27, right? So 2 into 3 cube, right? So what is the LCM? That is equal to 2 to the power of 5 into 3 cube. So that is equal to 32 into 27. Now 32 into 20, 32 into 30, sorry, 27 into 30, 810, right? And 27 into 2, 54, that is equal to 864, right? This number is exactly divisible by these numbers, right? 864 is exactly divisible by these numbers. Now what we require? Greatest number can be subtracted from 10,000, then the remainder may be divisible by these numbers. Here the greatest number, right? The greatest number must be subtracted from 10,000. Now what can we do? Here we will subtract 864 from 10,000. What happened? This is equal to 6 and this one equal to 319. See, what is the answer? 864 or 9136? 864 is exactly divisible with these numbers. But How will you get this 864? If you subtract 9136 from 10,000, then you will get the value of 864, which is exactly divisible by these four numbers. So what is the answer? Option B is the correct answer. Next, 27. What is the least number when lessened by 5? Lessened by 5 is divisible by 36, 48, 21 and 28. That number must be here. That word is divisible by, so that number must be a common multiple of these numbers. What are the numbers? 36, 48, 21 and 28. This is equal to 2 square into 3 square. This is equal to 2 to the power of 4 into 3. This is 3 into 7. This is 2 square into 7. Right? So what is the LCM? 2 to the power of 4 into 3 square into 7. Right? So 16 into 9 into 7. So this is equal to 16 into 63. This is equal to 1008. Now, this number is exactly divisible by all these numbers 1008. But what is the question? What is the least number when lessened by 5? Which number? Suppose if you subtracted from 5, if suppose that number is equal to x, if you subtract a 5 from that x, then only that number is equal to this number 1008. How will you get? Simply you will add 5 to this number 1013. See, if you will lessen 5 by this number, then that number is equal to 1008, which is exactly divisible by 36, 48, 21 and 28. So what is the answer? Option C is the correct answer. The smallest perfect square number which is divisible by 12, 15 and 24. Suppose if any number x is a perfect square, how will you find? First you will convert that x into product of the prime factors. Base must be a prime number and power must be an even number. Then only that number is a perfect square. Let us take an example. Suppose here a power x into b power y into c power z. When this number is a perfect square, here a, b and c must be belongs to prime number. And next, what about x, y and z belongs to even number. Then only this number must be a perfect square, right? Base must be a prime number and power must be an even number. Then only that number is a perfect square. Now, here the given numbers are 12, 15 and 24. First we will convert this number into product of the prime factors, right? Why? Because this number is exactly divisible by these numbers. That means the number must be a common multiple of these numbers or not. This is 2 square into 3. This is 3 into 5 and this is 2 cube into 3. Now, what is the LCM of these numbers? That is equal to 2 cube into 3 into 5 or not. 2 cube into 3 into 5. Now, this is not a perfect square. This is not a perfect square and this is not a perfect square. How will you get a perfect square? If the power is equal to even number. What is the next even number? That is equal to 4 or not. Now, you will multiply this number with 2 into here 3 power 1 and 5 power 1 or not. This is not a perfect square. When this number becomes to perfect square, you will multiply this number with 3. This is not a perfect square. When this number becomes to perfect square, you will multiply this number with 5, right? So this is equal to 2 to the power of 4 into 3 square into 5 square, right? So that is equal to 16 into 9 into 25. That is equal to 3600 is the correct answer, right? Option D. Suppose if you go through options, these three numbers are not a perfect square. 3600 is a perfect square, then that is the answer. But concept is this one. You must thorough with concept, right? Unless until you thorough with the concept, you can't do anything. you don't depend on the options, right? Next question. Product of two co-prime numbers is equal to 117. Their LCM should be. Already we discussed in the previous videos what is the co-prime. The common factor of any two numbers is equal to 1. Those two numbers are called as co-primes, right? The common factor of two numbers is equal to 1. Those two numbers are called as co-primes, whether those two numbers are prime numbers or composite numbers, whatever it is, right? Here suppose the two numbers x comma y. What is the product? X into y is equal to 117. Already we discussed in the second video. Suppose if you know the two numbers a and b, product of two numbers is equal to HCF of AB and LCM of AB or not. HCF of AB into LCM of AB. Suppose if you take two numbers, two co-primes, what is the HCF? Must be common factor of only one or not. Here x into y, let us take a into b, that is equal to 117 is equal to, what is the HCF? That is equal to 1 or not. Why? Because if you take any two co-prime numbers, what is the HCF? Must be 1 into LCM. So what is the LCM? That is equal to 117. Option A is the correct answer. See, if you take any two co-prime numbers, the HCF must be 1 and LCM must be product of those two numbers. Next example. Three men A, B and C go walking around a circle 1 kilometer. 1 kilometer in a circumference at the rates of 10, 20 and 40 meters per minute. 10, 20, 40 minutes per minute respectively. If they all start together and walk the same direction, when will they again together at the same place? See, what is the speed of A? 10 meters per minute. What is the speed of B? 20 meters per minute. What is the speed of C? 40 meters per minute. See, how much time is required to cover the 1 kilometer by A, B and C? That's what we require. Right? Here A, B and C. Total distance 10,000 meters. Why? Because 1,000 meters. 1 kilometer. And what? B 1,000 and C 1,000. What is the speed of A? That is equal to 10 meters per minute. What is the speed of B? That is 20 meters per minute. And what is the speed of C? That is 40 meters per minute. How much time taken to cover 1 kilometer by A? That is equal to 100 minutes or not. How much time required to B to cover 1 kilometer? That is equal to 50 minutes. And next one, how much time required to C to cover 1 kilometer? That is equal to 25 minutes. For every 100 minutes, suppose this is a one circular path. Suppose this is a one circular path and this is the starting point. Now, how much time taken by A to cover this entire distance? That is equal to 100 minutes. How much time required to B to cover this entire distance? That is equal to 50 minutes. How much time required for C to complete this entire distance? That is equal to 25 minutes. What we required? When will they again together? So that is nothing but that number must be a multiple of these three numbers. What we required? Common multiple of these numbers. Here the numbers are 100, 50 and 25. What is the LCM? That is equal to 100 minutes or not. So what is the answer? After 100 minutes, all are meet together. That's all for this video. In the next video, we will discuss another 10 important questions. Thank you, one and all.